Okay, can you hear me?
Yes.
Then okay. Can you see the PDF file?
Right.
Yeah.
Okay, then I will start today's lecture. I'm going to present about the ocean plant engineering. The contents of this part is HSFAS project, stakeholder in an EPC project, trends on ocean EPC project, collaboration among domain experts, schedule delay and start, and ICT in its EPC project. Before I start to talking about the EPC, ocean plant engineering, I'm going to talking about the founder of HHI, Hyundai Heavy Industry, Mr. Chung. He started shipyard construction in 1972 and have a contract with the two oil tanker. And it is the picture of Mr. Chung, and we are going to talking about this contract, how the contract is made for the ocean system, ocean plants. So first, let's see one typical project. It is FPSO project. It is Samsung Heavy Industry built this CPF, Central Processing Facility, and DSME Daewoo. They have a contract about this FPSO, floating production storage and offtake vessel. And why they need these kind of ocean plants? To think about this, we should know about the supply chain of offshore oil and gases. At the offshore and oil and gases, they need to drill the well, and they have a subsea system to processing and pumping, and they move gas and oil to customers to supply oil and gas in the offshore to customer. They need a transport tanker and also an FPSO to product and change the state of the oil and gas for the optimal form to transport to the tanker. So the Samsung built this and they will build this. Then how the client make a contract with this heavy industry company. In this project, the impacts the Japanese company and the Total E&P Australia, the Australian company, have a joint venture, and they doing a HS project. And for the offshore, they need to build the CPF and FPSO, and they order it to the company to build it. Then how the contract is made? In normal case, the company client is the big oil companies such as BP, British Petroleum, ExxonMobil, and Royal Dutch Shell. And they make a contract with the EPC contractor, such as Technip and JGC. And this company is make a contract with the subcontractor, heavy industry companies, and the supplier. These suppliers are going to give some electrical components or the compressor, gas turbines, that mechanical components to the subcontractor, and the subcontractor will make the power plants not power plant, sorry, ocean plants to the client by the EPC contractor. Then what is the EPC contract? EPC stands for engineering, procurement, and construction. In EPC contract, the contractor will design the installation, procure the necessary material, and construct it. They may build their own labor or by subcontracting the part of the work. The contractor carries the project risk for the schedule and budget. It calls the lump of LSTK, lump sum turnkey, depends on agreed scope of work. This main function of contracts is define the scope of work, define the technical requirements for the client's needs, describe the condition of the delivery, and ensure the correct payments at the correct time from the company to contractor. I say that the schedule and the budget, and they define the risk sharing when if the project is failed, and protect the company from the failure in delivery by contractor, and provide performance incentives for the contractor. And it usually is the risk for the schedule. Or remember, the time is gold. This is the image from the Fiat Tech that is about the BIM and BIM. This planning schedule can be simplified in this: basic design, engineering, procurement, construction, maintenance. You may notice that this engineering, procurement, and construction is the EPC. In past days, the client do the basic design, and they put design to engineering company, and the client buy and take the care about the things to build, and they do another the client do the another contract and subcontract to contractor or suppliers to construct the client's needs. And when the clients receive the plans or things, the client do the maintenance. In nowadays, we have this EPC contract. The client have the basic design, and they do a EPC contract to EPC contractor, and the EPC contractor do EPC company do engineering, procurement, and construction, and give the complete products to the client, and the client doing the maintenance while the client using the outcomes. In future, the work integration has a higher risk, but it means that higher returns. These 5 things can be integrated in client and contractor and engineering company and supplier. But this EPC contractor company is such as this Technip is one of the biggest company. It is very small company than the Samsung Heavy or Hyundai Heavy. Thus, if this it is delayed, then the EPC contractor company can be collapsed. So they changed in these nowadays. They have another type of service, just EPC management service. EPC management service to help the owner to work with the supplier, construction contractor, and other contractors. It can reduce risk and time on contract price, procurement, and increase the quality and performance, and have a higher owner involvement because there is no EPC contractor, and there's less step between this owner and the other and subcontract company. company. So nowadays, the EPC management is a new way to make ocean plant and or the big project. Now let's watch the video from the technique that the EPC company. Go to now. Let's go back to the lecture. So we see the video from the EPC company and what task in the EPC contract and why the reason they can be a failure. The task in EPC contract is including equipment supply, supplier section, cost of supply, process warranty, project financing, and legal costs may be lower. This EPC company are going to supply the equipments, and they select the supplier, and they scope of the supply and warranties to process, and project financing usually go down payment to the EPC contractor, and the legal costs may be lower by only one contract. And the failure that the EPC company may have is the requirement is unclear, or the lack of agreements between the client and EPC company, lack of priority, and so on. And the other problem is resources, including the human resources and the other kinds of resources. For the schedule, the schedule is too tight or unrealistic. They need to pay a fine for the late. And the planning in the data is wrong or the detail is wrong. They have a wrong plan, have a wrong returns, and the risk undefined, unassumed, that kind of risk may failure for the EPC company. And this is the reason why they changed the EPC contract to EPCM contract, because the EPC company is not that big, so they have a limits on the resources. To make EPC for the project, they have EPC, and the engineering part needs a collaboration among lots of experts. They need to think about INC, layout and piping, process, electrical, equipment, civil, and HSE. HSE is the health, safety, and environment. This kind of large area experts need to collaborate to build a successful project output. And it's another view. And for the activity as the project begins, they have a lots of activities, and for each activity, this table shows that for the each activities and need engineering types to success this. For example, for architecture drawing, they need an INC engineers and electrical engineers to success the architecture drawing. So, any questions so far? Okay, then I will begin. I will go in. So, this ocean plant project has a risk we said, and they can arise from the plant project. Each project has a different specification for the needs of the client's equipment and design. And they need a different procedure for example, design, construction, survey, validation, and test. And these different specification can may lead to the cost increase due to the increased number of the equipments, and the delay in procurement and the test equipments and material may delay the total project time, and it can be a financial loss. And schedule delay, in this new procedure for each project procedure, and the domestic equipment supplier cannot join the procurement process due to the high specification, and it may increase the total project time to do EPC product. So for example, the Samsung Engineering Company, they say that one specification, one code, and one transaction, one entry, one site, and one UI for the one project. They do not have the same kinds of these things in different type of project. So and I'm going to talking about the ocean plant standards. The big three shipyards of Korea start the standard with ABS, American Ship Society, in 2015. They have standards of the material, design, and procedure. They have standards for the material to build the plant, and standards of design of the plant, and they have standards of project management for the design, construction, QC, and the safety management. Okay, nowadays, this EPC project are joined with the ICT information and computing technology. They are helped by IT technology to make a model and procurements and construct the final design. This happened because as the time goes on, the project need more application. Project can have more application and they have more tags and documents. The project needs are going to complicate it, and they have more tags and documents which they cannot do in on analog. They need help from the ICT information technology to do a complete EPC contract. So, for example, they have a piping modeling and electrical and control modeling, and AFC PNID and AFC 3D modeling have like a 3D. And this is going to use for the procurement and construction. And this is end of my presentation. Do you have some question? No question. Okay, and thank you for listening.
Professor, your mic is turned off.
Thank you. Right. So it is about design. Originally, it is prepared by Professor Daejun Jang of Ocean System Engineering. There are some examples of oil and gas plant installations. So deep water field layout. So you see that there is a ship-like plant and semi-submersible type ocean plant. And this is a jack-up tile with fixed foot. Foot is on the sea bed. So the function is very similar. You see that there are real, oil well, where the oil or gas is coming. It looks like isolated holes with a white and also sometimes yellow. And they produce oil or gas. And then these output is gathered together by a pipeline on the seabed. So there are small different terminology, like a tie-in system, manifold with trees, well control system, satellite subsea trees, subsea processing, manifold, trees, and then drilling system, and then riser. The riser is coming from the seabed toward the ship or offshore plant. We call this is a vertical risers. And sometimes if the riser length is long, then they use this kind of technique to lower down the stress at the top bottom of the pipe because of the weight of the pipe and the oil and gas. If this length can be, say, 1,000 meters, then the weight itself is very high. So then there can be a problem with the connection because of the big force and pressure. And then this one is already explained by Ki-hun. You may see that there is a timeline starting from well drilling. So we start from drilling whether there is oil or gas to find out. And then if there is enough, they found that the reservoir is good, economical, then you start from installing subsea systems. How can I use spotlight? Let me try this one. So, and then so subsea system is to cover at the bottom of the seabed. And then there is a production. Production is to produce oil and gas. And there is a fixed platform like this one. This is a fixed platform. And FPSO and other FSO. So production is missing, then storage and offloading, floating. And there is also can be a pipeline. Pipeline is something like a seabed pipeline, this one. You can only use pipelines without any riser. And then you need to, after production, you need to have a transportation. And the land side, you need also supply way of to the customer or homes or buildings. Usually they are using pipelines. Or for the oil, there are many trucks, tank trucks. Let's see another one video about FLNG. Also the technique, FLNG.
An FLNG is a floating facility that liquefies natural gas directly above an offshore reservoir with periodic offloading of the LNG product to shuttle tankers. With a solid track record in the design and delivery of FPSOs, LNG and subsea, TechnipFMC proposes a full range of services from the early concept definition phase through to engineering and execution. As a world leader in subsea projects, TechnipFMC offers its expertise in the design, construction, and installation of all subsea facilities, including in deep water. The turret anchors the FLNG to the seabed and allows it to rotate according to wind, waves, and currents. From the composition of the feed gas, TechnipFMC develops the optimum process and designs all the topside modules to receive the gas on deck from the wellheads, pre-treat the raw natural gas to remove CO2, water, and mercury. NGL is also removed with co-production of LPG and condensate when the gas is rich. Finally, the gas is liquefied in cryogenic exchangers using powerful refrigeration systems. The FLNG is designed to store a large quantity of LNG plus condensate and LPG as required. The LNG is stored temporarily in highly insulated tanks at atmospheric pressure and around -160 degrees Celsius. The LNG is then exported through LNG carriers. The LNG carrier is loaded side by side with the FLNG using marine loading arms. Where side-by-side offloading is impossible due to the site mid-ocean conditions, or if the client prefers otherwise, Technip FMC with high-load LNG proposed the high-load LNG parallel loading system. This system, developed from proven and qualified technologies, allows offloading operations under harsh environmental conditions into conventional LNG carriers, a real breakthrough technology. The condensate offtake is through a conventional offshore offloading system. The FLNG is fitted with living quarters to accommodate operations and maintenance staff. Technip FMC, your reliable partner, an undisputed leader in FL.
Okay, so that's a video. Then can I move to right, so this is a video, PowerPoint. And so this is the for drilling unit. Drilling is at the beginning stage of oil and gas refiner oil field. So there is three different types. One is a semi-submersible type, and jack-up type style, and drill ship type. So we already see this one here. This is a jack-up style, submersible type, and ship type. So there are three different styles, and we'll see another video about jack-up style, how they operate. It's not coming. No. What is happening? Try again. No. Something wrong with my notebook. Okay. Try again. Okay, it's coming. So semi-submersible looks like this one. And they have a very small water plane area because of the strut. And the buoyancy is supported by this submersible pontoons, because they want to have a less motion due to waves, and mainly wave. There is the idea behind the semi-submersible type ocean plant. And this is a ship type drill ship. So the function is same, but how they want to make a buoyancy and motion during the wave and storm, there is a difference between two types. And then the drill pipe is coming in this way, using drill tower. The functioning is same. Okay. And this is jack-up style for the shallow water up to, say, several hundred meters. It's better to use this kind of jack-up style ocean platform. It was popular in Gulf of Mexico, where the water depth is shallow. But nowadays, they goes into the deeper and deeper ocean because the reservoir is empty. So that nowadays more and more semi-submersible type or ship type ocean plant is more popular comparing to the old days. Okay, and the top side, it looks like this one. Very compact and complicated. And also they are handling oil and gas. There are high level of safety requirement because it can explode. And also fire risk is high. So, but also they need a very compact construction because of the cost and space. And this is very special construction coming from Norway. They made jack-up style, but they make this construct as concrete rather than steel plate. And you can see from comparing with the size of Eiffel Tower, you see that the height is more than Tower of Eiffel in Paris. So you may expect that the construction of this kind of troll A was very strong and long, takes time, and many concrete cement blocks are used to construct. And final operation looks like in this left-hand side image. So the main strut submerged down to the seabed, seafloor. And this is a LNG FPSO. They use LNG for, and also this left-hand blue colored ship is LNG carrier. So this FPSO, they produce and store the LNG, liquefied natural gas. And when the storage space is full, then they call a ship to carry LNG to the land site. And it is just enlarged image of the LNG carrier. And they have a special unit called regasification, because LNG is should be very low temperature to be liquefied, minus 200 centigrade something. So in natural temperature, there should be small gasification, gasify the liquid. So the pressure of inside the
Can you guys see my screen? So for today's discussion, I chose topics related to offshore ocean engineering. So the first topic is about harvesting ocean energy. So ocean energy can be roughly divided into non-renewable and renewable sources. It can be roughly divided into non-renewable and renewable sources. So for non-renewable sources, these are your crude oil and natural gas, which can be extracted from underneath the ocean bed. And offshore production of this kind of fossil fuel makes up about 30% of the global crude oil output. So it's a substantial amount of energy that we can get from the ocean. And a typical crude oil powered gas turbine is about 500 to 1000 megawatts. So keep this in mind, because in our discussion topic, we are going to discuss if it is feasible for us to replace non-renewable sources of ocean energy with renewable sources, such as offshore wind turbine, as you can see here, then tidal turbines, Wells turbine, and point point absorbers. So, well, I guess I don't have to introduce wind turbine. It's very ubiquitous, and an average wind turbine makes about 3.6 megawatt of energy. If you compare this to a gas turbine, it's very less compared to a typical crude oil powered gas turbine. And I'm going to show you two videos that will explain how tidal power works.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
So in this video, we learned about how tidal energy from ocean tide can be used to generate electricity. The largest tidal power tidal power station is in South Korea in Shiwa Lake, and each submerged turbine that is used generates over 25.4 megawatt of energy. So it's roughly 8 times more energy than your typical wind turbine. And another novel idea is called a Wills turbine.
One concept for harnessing the wave energy is the oscillating water column principle. The power takeoff for this technology is typically an air turbine. The most commonly used air turbine for this application is the Wells turbine, which we will explain in this episode. The water level in the chamber rises and falls with the rhythm of the waves and act as a piston. The air is forced forwards and backwards through the turbine and causes the rotation of the turbine. This generates mechanical energy that is converted into electricity by a generator. The Wells turbine has a special feature: it always rotates in the same direction, regardless of which direction the airflow comes from. How is this possible? This is feasible because of the symmetrical shape of the rotor blades. As the air hits the rotor blade, most of the flow is deflected in one direction and pushes the blade in the opposite direction. Due to the symmetrical shape of the rotor blades, the same effect happens when the airflow comes from the other direction.
So this is a Wells turbine, and as we have seen, it generates electricity by using wave energy as well. The largest Wells turbine is in Island Isle in UK, and it creates a total of 500 kilowatt from 2 Wells turbines. So it's still very low compared to the other sources. And another is point observer, which generates energy by utilizing the heaving movement in the ocean. So the discussion point here that I want to discuss. Do you think would it be possible to replace non-renewable ocean energy sources with renewable energy? And do you think renewable energy and non-renewable energy should coexist, or it should replace non-renewable energy?
I think totally replacement is very hard because renewable energy, the case of non-renewable energy, it is easy to transport from far sea to land. But in the case of renewable energy, most of them are generating electricity. So transporting electricity is very hard. So I think that's the one reason, because most of renewable energy generators are in the beach side. So I think it is hard to replacement. But the case of coexist, we can use that renewable energy for you can use renewable energy for non-renewable energy plant, like some electricity or for light or such something like that. So I think replacement is hard, but coexist is possible.
Oh, okay. Can you hear me?
Yeah.
Yes.
I think it would take really long time to. I mean, if it's impossible to replace non-renewable energy sources with renewable energy sources. So if you take renewable energy sources, we have discussed about wind turbines and also from tidal power source. So those usually, they mainly operate, for example, say wind turbines operate when wind blows. And also if you take solar energy, that works only when the sun shines. So there are cases where those cannot, like, do not happen as you stated. As it's stated in the video, for tidal energy, it doesn't match the demand. I think the time sometimes, like, there's offset. So when we need the energy, we may not get like the energy we want from mainly the renewable energy sources. But if you take non-renewable energy sources like coal or gas, I mean, it may, after some time, we will have like kind of we may how can I say, the supply may decrease, but in the long, that's the really long range. We are still like, we still have them. We can use it now at least at the current time if you when we need it. But for non-renewable energy, even at this time, it may not like give us a constant supply of energy. So maybe using them as an alternative energy source side to side, like is a non-renewable energy source coexistence, that's possible. But maybe in the future they may replace, but I don't think that's really possible.
I agree with others' opinion. Finally, after a long time, it is likely to renewable energy sources can be replaced with renewable energy, such as wind, tidal, and solar energy in the future. However, considering a lot of energy consumption nowadays, at present, it is expected that it will take a lot of time because a lot of amount that can be replaced by renewable energy is not enough now. And in addition to this opinion, compared to non-renewable energy sources, the negative impact of renewable energy sources would be small. This is because partial energy this is representative of non-renewable energy, has to dig the ground or deep seabed. This kind of thing lead to the adverse effect on environment.
And I have a similar idea with Yoon's idea. I think they might replace the renewable energy in the electricity which is using in the beachside city or in the city, and they can use this energy for the electricity for the country. But I think they still need to use a non-renewable ocean energy, oil and gas for the transportation, and not the train or car, but the ship. And they need also they need a non-renewable energy, not for only the energy source, but they need to make a plastic. All of the plastic came from the oil and gas. They change it to naphtha and change it to plastic. So they still need that non-renewable ocean energy source. It not for using for energy, but to use on the chemical ingredients. And for the energy case, they cannot drive the large container ships with the electricity. They need, by using to move it only with electricity, they need a huge amount of battery in the ship, which don't make sense to drive the ship. So I think they still use the non-renewable ocean energy for the ships, even if they can supply all the country's electricity with the renewable energy.
And also maybe can we go to the back to the wind slide, previous slide? I think that the number is much smaller than I expected it to be. This is just 3.6 megawatt.
But note that this is only for one turbine, so usually there will be a lot of.
Sorry?
So this is the power for one turbine.
Oh, okay. Still, it's like very inefficient, right? And expensive, maybe.
Yeah, you can say. Compared to tidal power, it's also way less dense, as was mentioned in the video, because air is less dense than water. So that could also be a reason why we can harvest less energy for wind. So I think the points mentioned for the first discussion is that it is difficult to transport electricity when it is renewables or when it is from renewable sources. So maybe that's why countries like Denmark are leading in this field. So secondly, I want to discuss about the ecological impact of renewable energy sources. Already, Kion has mentioned about using oil to create the plastic. So that's one important source of ecological damage for renewable energy as well. And so yeah, so the reason we are moving to renewable energy is because non-renewable energy sources are very polluting, like oil spills, causing climate changes, and that is causing disruption to the oil environment. So, but do you think renewable energy sources are any better? Do you think, what do you think about renewable energy sources and its impact on the ecology? So, for example, it is also well noted that building wind turbines in ocean destroys the marine life, something like that. Do you guys have any thoughts about it?
Compared to the solar and wind energy, tidal energy may lead to harmful to ocean environment because I think it could be barrier in ocean, so it may risky to ocean environment.
Anyone else have anything else to add?
So, okay. Obviously, renewable energy sources, the impact they make in the environment is not as much as non-renewable energy sources, but still, I think there would be a small impact, but not that much, that bad. If you take, for example, solar energy sources, so to make the solar cells, you know, it doesn't come out of nowhere. It has to be manufactured using different materials, special materials, and to make those materials, we also have to spend some amount of energy, and that means we are going to, although it's not that much to make influence in the climate change or something, but still that would affect the environment. But taking the fact that the energy produced from it is clean, I think it's worth it, but still there will be some kind of impact on the environment.
I think that the environment's effect of the renewable ocean energy source is depend on the case by case. For example, the tidal plants you say the Xihua is built on the failed land reclamation project, so it is already have a large impact on the environment. Then the having on put a tidal plants on that kind of place is not that a big problem because the environment is already disturbed by human. But have to but make a new plants or on the fresh wetland and mods, then and they destroy the environments before it exists, then that can be or not be a big problem. So I think that the renewable ocean energy source on the environment impact is the case by case due to the place it is built.
And I only have idea about tidal energy because tidal energy has low efficiency, so we have to make it more higher. For that, we have to optimize our environment, like build some buildings or change the coastline or something like that. So it destroys the natural environment, and as Kian says, it can destroy some habitats about that part. So I think that can be some possible problem.
Also, I think related to this topic, there is recent news in Korea. Maybe I think the government decided to use offshore wind turbines. I think in certain island, and the fishermen in that island were, I think, protesting or something. I'm not sure about the details, but so some renewable energy sources may also cause issues related to habitat and also displacing some people because it takes a really like wide area.
Thank you so much for your points. The second topic I wanted to discuss about is offshore spaceport. So what's a spaceport? So Elon Musk company SpaceX is buying oil rig and it is repurposing them to turn it into a launch pad and also a landing pad. And also inside the spaceport, there will be, let me just show you a video to explain it.
Elon Musk is taking over the sky and the sea. As you stand on the shore and look out to the water, you will see a huge floating spaceport. It feels weird to say this out loud, but it also is kind of fun. That's where your journey to Mars will begin. SpaceX recently bought 2 floating oil rigs dubbed Phobos and Deimos that will be converted into seafaring launch pads for the SpaceX Starship. The rigs cost $3.5 million each, and SpaceX will spend millions more converting them into spaceports. These spaceports will be equipped with a launch pad, elevator, access arm, fuel tanks, control room, and enough space for a Starship and Super Heavy booster. Here's what one of these floating spaceports will look like. All right, hop in the boat and let's ride out to the SpaceX floating spaceport. Despite the transformation, you might notice some holdovers from its days as an oil rig. The pontoons that make the spaceport float are the same as they've always been, and the large concrete legs that rise above the water are also unchanged. The cranes and drills are gone, and the main deck has been expanded to add room for a launch pad and 4 landing pads. You'll notice a landing pad in each corner. This is where the huge tankers unload Starships that have traveled all the way from SpaceX production facilities in Boca Chica, Texas. These landing pads are also used by Starships traveling around the world. The SpaceX Starship doesn't just take people to Mars. You can travel from a floating spaceport off the coast of New York all the way to a spaceport off the coast of Shanghai in just 30 minutes. A trip from Toronto to Los Angeles takes just 24 minutes. Traveling from Bangkok to Dubai takes just 27 minutes. And a trip from Tokyo to Singapore takes a mere 28 minutes. You'll never fly in a plane again after traveling via Starship. Most flights cost $1,000. It's not too much cheaper than a plane ticket, but you're saving a lot of time. In the center of the main deck, you'll notice the launch pad where the SpaceX Starship will take off. The orbital launch mount, Super Heavy booster, and Starship itself sit on the launch pad. Right next to the launch pad, you'll see the elevator and access arm, which will take you inside. But let's take a look inside the spaceport before we take off. You can't see it when you're standing on the main deck, but there are fuel tanks hidden inside each leg of the floating spaceport. Each leg contains 4 tanks, so there are 16 tanks total, which means there is enough fuel on board for multiple launches. Fuel connectors on the side of the spaceport connect to a series of pipes that carry rocket fuel to the tanks. Tankers float up beside the spaceport to unload the fuel needed to propel SpaceX Starship into orbit. This fuel is extremely valuable. Each Starship launch uses $900,000 worth of rocket fuel, and each launch will cost $2 million total. The SpaceX floating spaceport contains at least $18 million worth of fuel at any given time. Let's head beneath the deck to see the brains of the operation. Launching a SpaceX Starship is a tremendous task. The engineers and flight controllers that monitor the launches are some of the smartest people in the world. Well, they better be. And they're paid incredibly well, by the way. A SpaceX flight controller makes about $100,119 per year. In case you were thinking of changing careers, there's a control room hidden beneath the main deck on the east side of the spaceport between the fuel tanks. The room is filled with rows and rows of computers, and large screens on the wall give the engineers a direct feed to astronauts in the Starship. Let's head out of the control room and take an access tunnel to the other side of the spaceport. This is the storage room. It's located on the west side of the structure between the fuel tanks. If you look around, you'll see space orbital launch mounts, diagnostic equipment, and welding equipment that's used to repair the SpaceX Starships. Those large doors on the east side of the storage room are used to move orbital launch mounts to the launch pad on the main deck. The mounts slide on tracks and are lifted up to the center of the platform. Let's follow it up to the main deck. Are you ready to blast off? Let's take a close look at the launch pad. Sliding doors directly beneath the launch pad are used to raise up spare orbital launch mounts. On top of the orbital launch mount sits the $40 million Super Heavy rocket booster that's used to send the Starship to Mars. Each Super Heavy rocket booster has 6 landing legs and 37...
So, as you can see, an oil rig like this was repurposed into a spaceport which has a control room and an oil factory, fuel storage facility, etc. So for discussion points here, I would like you guys to talk about what are the possible environmental and ecological factors that might happen due to launching ships like this. And do you think just like air travel, this kind of ports can cause congestion in the ocean and in the ocean?
Yeah, on the last point, that I was surprised about the transportation from New York to Shanghai in 27 minutes or something. That's really magnificent. I think if this happens, then plane travels would be obsolete and people won't be using them anymore.
Anyone has anything else to add?
I think it seems that offshore port for rocket takeoff is possible, But to make it possible, I think it must be able to prevent the dangers from the tsunami or high wave and other environmental costs. If the offshore port for taking off and landing of a rocket is developed, then noise pollution on land could be dramatically avoided. But I think it would be important to select a suitable and specific location that could be minimized the impact on marine ecosystem.
And I think that having a ocean spaceport can be a good idea because there is a lack of land near the equator to make a spaceport. It is well known that to launch a spaceship near the equator, it have a benefit on the speed because of the Earth rotation. But there is not enough and not enough good lands near the equator. So having an artificial floating offshore spaceport at the equator, it can be a beneficial to launch a spaceship.
Also, as it's stated, usually if you notice, NASA space missions are launched from Florida. There is a place called Space Coast. It's on the eastern side of Florida. That's selected because for rocket launch, because of the rotation of the Earth, it has to be, in case there is any malfunctioning, the debris should fall like on the ocean, or at least if it's on the ground, it should be somewhere where there are no people, like uninhabited land. So in the US, there were only 2 options at the time. Texas, around like the place now, SpaceX is building offshore spaceport in Florida. So they selected Florida because the place in Texas around that place, they were like really urban place. It's a place close to Houston, and like it's there is a big metropolis. So they selected Florida because it's first on the eastern coast, and second, there are not a lot of inhabited lands around. So they had only two options in this case, and US, as you know, is a really big country, and that means using offshore spaceport would give like countries like Korea, for example, or other smaller countries first who doesn't have like that much area, and also which are not close to the equator, as Gion mentioned, would give such countries a great opportunity to have like their own launching place. Yeah.
Actually, before I watching that video, I was thought like the problem of transportation of that oils and spaceships, but that kinds of problems could be solved as spending a lot of money. It can be solved as the video says, and I also agree about what Bracket says. There is some countries has very small land, and it's hard to build a spaceport, and I agree with that point also. But while watching that video, the beginning of that video says from Tokyo to Singapore it is 28 minutes, only 28 minutes. But the point is the spaceport is in reach at ocean, then we have to take a ship from Tokyo to Tokyo spaceport, and Tokyo spaceport to Singapore spaceport, and Singapore spaceport to Singapore by ship. Then it could be spend more time for traveling by ship, and so I think that's irony.
Thank you everyone for the great points that was made. So with that, I think we had a good discussion, and with that, I would end today's discussion. Thank you all for listening and participating.
Right. So we have a good discussion and long discussion. Very nice. So see you on Thursday then. Right? Right now.
Okay. Thank you.
Thank you.
Bye.
Thank you.